42 in the following exercise, solve the following system of equations by substitution. X equals 2y and 4x minus 8y equals 0. And again, what we looked at in the previous video, in the first example of substitution that we looked at, we discussed asking yourself really two key questions to begin with. Is one of the two equations in your system already solved for x or y? If it is, then you're sort of ahead of the game. And in this case, we're sort of ahead of the game, right? Because we can see here in the first equation, the variable x is all by itself. It's isolated on the left-hand side. There's nothing else on that side of the equation. So this makes our job a whole lot easier, because what we're going to do is we're going to take the value of x, which is equal to this expression 2y, and we are literally going to substitute this value into the second equation wherever we see an x, right? So in the equation 4x minus 8y equals 0, we know that this x right here is equivalent, has the same value as 2y. So we're going to make that substitution. And maybe what I'll do is draw the arrow the other way, because that's the, the substitution that we're going to be making. So let's go ahead and do that. So 4x, but x, of course, will now take on the value of 2y minus 8y equals 0. Let's clean this up and see what we end up with. So when we distribute this 4 times 2y is 8y minus 8y equals 0. Combining like terms here on the left-hand side, 8y minus 8y, well, that's 0, equals 0. So notice what happened here. All of the variables eliminated. They disappeared, right? There are no more variables left. And we are looking at a mathematical statement that is ultimately a true statement, right? This is true. The number 0 equals the number 0. Those two things are equivalent. And so this is one of the scenarios that can happen in your system of equations when your variables eliminate and you're left with a true mathematical statement. What that ultimately means is that you have a system with infinitely many solutions. Right, so we looked at what this means graphically in the first couple of videos, right? When you're dealing with a system that has infinitely many solutions, what it really means is that these two equations are really the same line. They're really one and the same. They're just expressed in two different ways. So if we were to graph these two equations, we would ultimately see that these two equations really are the exact same thing. They're the exact same line, but we don't have to graph. We can use this more algebraic approach, in this case, substitution. So in question 42, we end up with a system with infinitely many solutions.